Circular queue. A circular queue is a linear data structure in which the last position is connected to the first position, forming a circle. So what this design does is it allows for efficient reuse of space once all the elements are dequeued from the queue. So let us say this is a queue. We'll start from where we left in the array implementation of queue. So from that, it will be easier for you to understand what exactly is the advantage of a circular queue. So when we used array implementation for queue, what happened? Whenever, let us say this is an array and you were implementing queue using this, let us say you had two elements. Initially, you enqueued, let us say 7 and then 5. Then if you want to dequeue, what will you do? You will just remove this value 7 and this will be the front. So what will be the next enqueue operation? Let us say you enqueued 6, 8 and 9. So enqueued 6 here, let us say 8 here and 9 here. Let us say you want to dequeue two elements. So again you dequeued 5 and then you dequeued 6. Let us say you want to add a new element 2. So you added it here. What if you want to add one more element, let us say 4? Will you be able to add 4 here? No, because your array space is already depleted. So in this case, in array implementation, even though you are having 3 empty spaces here, you are not able to enqueue a new element because of the way elements moved forward. And during our array lecture, we had told that the solution for this is whenever you dequeue, you will move all elements one step towards left. So in each dequeue operation, you will move all the elements to the left, which means instead of 892 being here, it will be present in these positions. But what was the disadvantage in this? You were having to use order of n time for each dequeue operation. So even though enqueue took order of 1 in array implementation, dequeue used to take order of n if you are shifting elements towards left. So if you want efficient memory usage, automatically your time used to go up in array implementation. How do you tackle this problem? The solution for that is the circular queue. So let us see how will circular queue tackle this problem of having efficient time complexity and efficient space usage. Let us get back to circular queue now. So you understood the problem that circular queue is going to solve. So here also we are using an array only, but the thing is we are going to consider that after this last position, the next position is first position. So you are considering it as a circular array. So instead of thinking like this, you can think of it like this. The array is something like this. You have all the array elements like this. It's a circular array. So if this is your front, this is your rear. So rear will depend on what is the number of elements you have. But if this is the last block in the array, after that the next block you reach is the first block of the array. This is the concept of circular queue. So for easier understanding of a mathematics, I won't represent it as a circle. I would represent it as a normal array, and you need to keep in mind that after the last position in the array, you will be using the first position. Okay. So in order to understand the mathematics behind, this will be easier. That is if I draw it like a normal array. So let us say my indices are 0, 1, 2, 3, 4, 5. So how does it work in a circular queue? The first thing, you should have a front and rear pointer. So for any queue, you will have this. Let us say there are some elements already here. Let us say 41, 50, 33. These elements are already here. So my front pointer will be pointing to the first element. This is my front pointer. My rear pointer will be pointing to the last element. So when I say pointer, remember these are arrays. So there is no concept of pointer here. By pointer, I meant something that keeps note of the index. So here front pointer means f is equal to 0. Rear pointer means r is equal to 2. So it would say index 2 is the one holding the last element. So consider this as a queue now. You will be dequeuing from the front, that is from front pointer. If you want to enqueue, you will increment the rear pointer to the next one and then you will enter the new element here. This is how you will enqueue. So let us see how each of the operations are done. So two basic rules in order to maintain the circular structure. first rule is that whenever your rear pointer reaches here, whenever it reaches the end, the next step will be to wrap around and take the rear pointer here. So whenever your space is depleted, after here, if you do rear plus 1, it should reach here, the first position. Similarly, if you are dequeuing, let us say you will dequeue. So this time when you are dequeuing, you won't move elements to the left. Instead, you will be moving your front pointer one step forward. So let us say you did dequeue 5 times. So from here, front pointer would have reached here. After this, if you want to dequeue again, your front pointer will also wrap around and come back to position number 1. That is 0 index. This is how the circular structure is maintained. Whether it be rear pointer, whether it be front pointer, when it reaches this position, the next step will be reaching first position, that is index 0. So this is the first thing you have to keep in mind. Next thing is how to identify if this circular queue is empty. If the circular queue is empty, you will have front as -1. So we'll come back to this, how it is -1. But just keep this in mind for now, that if the circular queue is empty, the value of front will be -1. Next thing, how do you identify it if it is full? If it is full, what happens? Let us say, after this you have more elements, let us say 21, 10 and let us say 90. So your rear pointer is here, front pointer is at 0. So how do you identify that your circular queue is full? Previously, if you reached here in an array, it was full. But because this is circular queue, after you reach here, you can again come back here. So how do you identify it is full? In order to identify it is full, you want to do rear plus 1. Then you have to do mod of size. So when you do this, if you get the value of front, that means it is already full. So if you here the size is what? Size is 6. So if you do rear plus 1, that will be 5 plus 1, 6. 6 mod 6, you will again get 0. So 0 is where front is at. So if rear plus 1 mod size, the size of the array, if that gives the value of front, that means your circular queue is already full. It is having overflow condition. So this circular queue, it eliminates the need of shifting elements and avoids space wastage. So let us see NQ and DQ operations, their time complexity and all these things. Okay. First of all, let us go to NQ operation. How does NQ operation work in a circular queue? So whenever you want to NQ, first thing is check for overflow. So how do you check for overflow? Check rear plus 1 mod size. If you do this, if you get it equal to front, that means it is an overflow situation. Your array size is already depleted. You cannot NQ in this condition. So in this case, you have to abort the NQ operation. If this is not the case, it is not an overflow condition, you have space in array. Let's say you have some space in array. This is your front, this is your rear. So in this case, first thing, update the rear pointer to rear plus 1. Make r is equal to r plus 1. So r will now come here. Next thing, add the new element. Let us say my new element is 40. So I'll add my new element in whatever is the new value of rear. And one more thing you have to keep in mind is that if before this operation the queue was empty, then you have to alter front pointer as well. Why do you have to alter front pointer? Because I told you that an empty circular queue is shown by front pointer equal to -1. So if the queue was empty, so how it is -1? Keep it there for now. Just understand that if the circular queue is empty, front pointer value will be -1. So if it was empty, your front pointer would have been -1. So presently you are manipulating rear pointer correctly, but your front pointer should be updated to 0. So this is the change you have to do in case the queue is empty. That is, let us say this queue didn't have these elements. It was fully empty. Then your front pointer value will be -1. So what do you have to do? You have to make rear as front as 0, rear also as 0. This is how you have to manipulate in case the queue was previously empty. If it is already having some elements, let us say some elements like this, then you don't have to touch front. Front will always be there at whichever is the first element. You just have to do rear is equal to rear plus 1 and you can add the element, let us say 30. So this is how NQ operation is to be done. So what is the time and space complexity? Time complexity, you are not moving elements or something, you are just manipulating a front pointer and a rear pointer, mostly only a rear pointer, and you may have to sometimes manipulate front pointer if the queue is empty. So it is an order of 1 operation, a constant operation. What about the space usage? You are not using any extra space, array space is already allocated. So space is also order of 1. So remember, for NQ, time and space are both order of 1. So even in normal queue, you had NQ operation at order of 1 time and order of 1 space. So nothing special here. DQ operation is where the change is going to come in, because in DQ operation in normal queue, you had order of n time and order of 1 space. So order of n time, we are going to decrease it to order of 1 by usage of circular queues. Okay. So what happens in circular queues? Let us say I want to DQ. First thing is I have to check for underflow. Underflow means if the queue is already empty, I cannot do any DQ operation. There is nothing to be removed. So how do I check if it is empty? You have to check whether front is equal to -1. If front value is already -1, that means the circular queue is empty. You can't do a DQ operation. So let us say front is not -1. My front is here, my rear is here. In this case, how do I do DQ? I have to do DQ from the front. So first thing, I will access the element that is at the front. So the element that is at the front is 10. So I'll access the element 10. I'll return this element wherever I have to return. The next step is I can move the front pointer forward. So I'll do front is equal to front plus 1. So my front will move to here. So this would mean 10 is no more counted. So here you don't have to explicitly remove 10 or something, because this whole array space is already allocated. You don't have to remove any memory. You just have to move the front pointer 1 step forward. So what happens now? Your front pointer is moved 1 step forward. This is your front, this is your rear. One thing you have to keep in mind is, if after your operation, if the queue becomes empty, in that case, you have to modify front and rear both to -1. So let us say I did DQ once more. What will happen? My front will reach here. So my front and rear will be in the same position. Let us say I DQ 21 as well. So now my front and rear are both at the same position. So when I am asked to do one more DQ operation, I know that because my front and rear are at the same position, if I DQ, this queue will be empty, because there is only one element now, 30. My front and rear are both at 30, which means this circular queue has only one element, which is 30. If I remove this, it will be empty queue. In that case, when I am removing, first I'll take the value 30, I'll return it to wherever I want. Then the manipulation I will do, I'll make front is equal to -1, rear is equal to -1. So this is what I have to specifically make in a circular queue. So for DQ, what are the steps? First thing, check for underflow. If there is an underflow, nothing to DQ, report it. Otherwise, just make front is equal to front plus 1. Whenever I say plus 1 in circular queue, always keep in mind it's not just a plus 1, it is plus 1 mode size. So wherever I have said plus 1, whether it be front or rear, whenever you have to do plus 1, keep in mind it's not just a plus 1, it is front plus 1 mode size. So that means if your front has reached here, when you do plus 1, it would take value 0. That is how it should be. So wherever I have said rear plus 1 or front plus 1, keep in mind it is not just a plus 1 in case of circular queues. It is rear plus 1 mode size, front plus 1 mode size. So whenever you are doing a plus 1, you have to do mode size in case of circular queues. So this is the DQ operation. What is the time and space complexity? Time complexity, I am just manipulating front and rear pointers. So it is an order of 1 operation. You don't have to move the elements. Space complexity, array is already allocated. I am not doing anything in DQ. So it is order of 1 space. So with the help of circular queues, my time and space complexity for all the primary operations on the queue will come down to order of 1. This is the advantage of circular queues. And So you already understood it uses space efficiently. All the primary operations come down to order of one, and it is easier to implement compared to linked list. So linked list also has order of one time and space complexity, but circular queue is easier to implement. So compared to array implementation, you are saving on time when you are using circular queues. And what is the disadvantage? Disadvantage is that the total array that is used for circular queue, this has to be allocated at the start itself. So you should know what is the total size that you want. Even though after allocation the usage is efficient, the initial allocation, whatever you allocate, that whole memory will be used throughout the process. So this is one disadvantage. So regardless of the actual usage, memory will be used. This is the only disadvantage. Otherwise, circular queues are the best implementation of queues, because you can have order of one for all the primary operations.